Okay, everyone. So now that we have basically completed our understanding of some simple summary statistics that help us interpret our data sets, we're going to look at ways that we can, we're going to look at some new tools. So we've been working in Excel so far, and of course Jessica shared pivot tables with us last week, which was also new material for me. And we're gonna move on from Excel now, and we're gonna look at another tool called OpenRefine. And OpenRefine is in some ways similar to Excel in that it kind of gives you a spreadsheet-like view of data, but it does a few different things that allow us to, number one, perhaps most significantly, handle larger quantities of data than Excel can do comfortably. Also it's going to help us too with some of those quick summary statistics that we saw with pivot tables, just sort of in another format. I find this a little bit more intuitive. Obviously, it's up to you all what you choose to use when you're doing your analyses, outside of the assignments, of course. So let's take a look. OpenRefine is actually an open source program that was developed, and then it was acquired by Google, and then Google sent it back out into the wild. This is already available on the lab computers. You are welcome to download this to your own computers if you want. We're not going to go over the setup in class. The thing that I want to point out here is that when you launch OpenRefine, OpenRefine actually runs in the browser. Okay, this is the landing page for OpenRefine. What this means is that we interact with it a little bit differently than we do with Excel. There's no right-clicking in OpenRefine because that's not an interaction pattern that you can really do in the browser. But it supports a wide range of file types, and as I said, it's better at handling, for example, large data sets than Excel is. So, as we've talked about, very often if I get a large data set, the first thing I'm going to do is look at it in a text editing program. OpenRefine also provides some ways to control how much data I import, which is handy, again, when I have large data sets. So I'm going to come back here to our city bike data set, of course, and I'm going to actually go for one of the larger files this time, right? So been kind of avoiding these because they were pretty heavy, right? There was a lot of data there. We'll see if maybe the September data appears to be maybe available. It looks like a pretty big file because it's taking a while to download. As you may be able to tell already, I'm actually on a different computer, so I'm actually not on an Apple computer anymore. So this may look a little bit different when you see it in class, but principally we're doing the same thing. So I'm going to open this up. And nope, that's not what I wanted to do. Stop. Don't do it. Oh goodness, well, that's a disaster. So we can already see that Microsoft Office is not feeling well. So we are going to try to kill this process. I'm going to close the program. I didn't ask you to check for anything. Okay, let's try this again. So I'm going to go ahead and drag this onto my desktop so that I can see it more directly. And again, I realize this is off screen for you all. In any case, now that I have downloaded this large data set, I'm going to come to OpenRefine and I'm going to select the file. So from here, I'm going to go to my desktop and I'm going to select Open, right? So very similar process, exactly what we would do with Excel. But you see that this says uploading data. Now, I want to be clear that actually when we use OpenRefine, everything is happening on your computer, okay? What it does is it sets up something that functions like a remote web server, except it's right on your PC or Mac. And the key thing there is just what it means is that sometimes people have concerns about doing data analysis, uploading data to services because they want to keep it private what they're dealing with. That's completely understandable. You are not uploading this to anywhere off of your computer. In fact, I don't even have to have Wi-Fi on to run this, right? So I just want to clarify that although this is happening in the browser and it uses language like quote unquote uploading, it is not actually uploading to any remote server. So one of the really handy things about this is that unlike something like Excel, which is going to automatically try to open the entire file, OpenRefine is going to show me a preview, as you can see here. It's a little cramped. So it's showing me what it guesses the the parsing of the data should be. Obviously, this is a basic CSV file, so it's nothing too complicated. But it does things like it offers me some options about how to handle my data set. So for example, by default, it's saying, hey, it says parse the next 1 lines as column headers. In other words, parse the first line as column headers. So it's going to treat those. So in Excel, again, where we kind of always have to do this separate accounting for our header row, OpenRefine will treat those as column headers and doesn't sort of confuse them with the data, which is really handy. Similarly, I can choose things like load at most, and I'm just going to pick a number here. I'm going to say 100,000. Okay, so 100,000 rows of data might be fine in Excel, might not be. It can go up pretty high these days, but more importantly, it's going to be a lot faster. You know, it's asking me how I want to store various types of data that might be in here. Again, I can choose custom separators, right? Custom delimiters if needed. The other thing that this does, and I think that newer versions of Excel do this too, is it's going to allow us to parse different file types, specifically JSON. So we haven't looked closely at the JSON associated with the city bike data yet. We will soon. But just to keep in mind that another thing is that this handles a lot of different data formats. So the first thing I have to do, of course, is save my data. So I'm going to say city bike September 1st 100. Okay, and I choose create project. And so, as you can see, that was actually really fast. How quick it is going to depend a little bit on your own computer, right, and what your computer's sort of capacities are, right, how fast your processor is. The nice thing about OpenRefine too is that if I need to deal with a large data set and I don't want to break it up into a million little, you know, I don't want to break it into smaller pieces or pieces that are as small, I can actually allocate more memory to this, right? So I can actually tell the computer, hey, I want you to give more of your processing power over to this program because, you know, this is what I'm focusing on. Okay, so what has happened here? So you'll notice, for example, that we're only looking at 10 rows of data. So the way that, again, the way that we interact with OpenRefine is substantially different from the way that we do with Excel because we don't do a lot of scanning. So, you know, in Excel, we did a lot of filtering. In OpenRefine, we're going to do things that are in effect filtering, but we call them faceting. Okay, so the first thing that we're going to do, again, so one of the main tasks that you all had to do is that you had to select your start station ID out of the particular data set. Now, in OpenRefine, rather than doing a sort and then selecting and copying and all of that kind of thing, what we're going to do is we're going to select this little arrow, right, which kind of substitutes for our right click, and we're going to choose text facet on start station ID. Now, what we're seeing here immediately is we are seeing a list of all of the options. I think hopefully you can see the parallel to pivot tables. We're seeing all of the options, right, that appear in this start station ID. And what we're seeing in the little gray number adjacent to that is the count. So we're seeing that start station ID number 116, or the value 116, appears 207 times. By default, this is sorting by name. I can also change it to sort by count. So if I want to see the highest, the station ID that appears the greatest number of times, I can do that using the, just by sorting by count and looking through it, okay? So right away, this is going to make our lives a little bit easier because if we want to choose a subset of data, all we have to do is do this facet thing and kind of look through for what we want. Now, if we want to just highlight just those station IDs. So again, for your assignments, one of the things you've done is you've kind of filtered, or rather you've sorted, and then you've highlighted and copied and pasted. What we're going to do here is we're simply going to select this, okay? So by default, now that that's highlighted in orange, what it means is the only things that I am seeing here are rows that have start station ID of 519, okay? And we know that there are 752 of them. So very similar to pivot tables, what this gives us is this gives us a very quick way to get some overview data, right? We can very quickly see, okay, which start station ID appears the most, right? We can even actually go ahead and there's a way to export this. So actually, if we select the choices, we can actually get the distribution, right? We can get that count, or we can get that count just as a tab separated text file, right? So we could go ahead and save this and say, hey, this is the number of times that each station appears in this set of data, right? So likewise, again, instead of doing sorting, copying, pasting, if I want to work with a particular subset of data, I can just select it by clicking on it here. And the other thing, again, too, is that I instantly know how many rows there are, right? It was in the metadata here, the 752, but it says 752 matching rows. If, for example, I wanted to select 2 or 3, if I were to choose a different one, right, it's going to be substitutive. It's going to choose that one instead. If I want to choose 3, right, I just choose include to the right here. And now I know that at these station IDs 519, 281, and 497, there are a total of 2,120 instances of those start station IDs appearing. So right off the bat, this is going to give us some really nice summary statistics. The other thing that I like about this that I find really handy is that if I want to create a subset, so let's say we're working with the first 100,000, as you all will for your assignments going forward, I'm going to select my particular station ID. And I'd rather not sort of have everything else in this file, right? I'd rather just focus on that. So again, in Excel, the way you do that is you create a separate sheet. What we're going to do here is we're going to actually export a subset of this data. So anything that I have selected here, if I want to create a separate data file with it, all I have to do is say export, and I can choose how I want to export it. I'm going to say comma separated value. Okay, and again, it sort of looks like a download here, but in fact, it is actually just saving it to my hard drive. Okay, I apologize. This is all sort of happening new. So I'm going to come back here. So that would be in my downloads folder probably. Again, new computer is set up. You can also do the save as, and that will, and you can save it as a different, with a different name, which you would want to do, generally speaking. Do not use, or you're not generally going to want to use export project. Okay, export project is a little bit different. It means to export this as an OpenRefine project, which is not going to open in Excel, for example. Now, some other things that we want to look at. You'll notice here, so for example, if I want to then kind of do a drill down, so let's say I'm looking only at start station ID number 519, and I want to do something like look at trip duration. Well, on its surface, I see numbers in here, and I want to do a numeric facet. Well, unfortunately, it says there's no numeric value present. And that's because when OpenRefine imports data, it doesn't make any assumptions about what kind of data it is. Now, this may seem like a drag at first. In my experience, it's actually helpful to not have the program try to make decisions for you about what kind of data is in a particular field. So what we're going to have to do is we're going to have to tell it explicitly and say, hey, actually, this is a number. I want you to treat it as a number. And so to do that, we're going to go to Edit Cells, and it says Common Transforms. And of course, we want to just say, treat this one as a number. Now, another thing I want to highlight here is that if I do this kind of change, sorry about that, if I do this kind of change on a subset of my data, so I only had selected the station ID 519 here, and I said, okay, turn these to number. What I will discover is, and if I want to remove that filter, I can just close this out. What you'll see is that it hasn't applied that action to anything that wasn't selected at the time that I did the action. So if I want to actually transform all of my trip durations to numbers, which arguably I might, I would need to do it on the unedited data set. I can do the same thing with start time and stop time, and the reason why this is going to be handy is I'm not going to change them to numbers, I'm going to change them to dates. So I say to date here, and I'm going to do the same thing here. Oops, I always go the wrong one here. And the reason why is that this is going to let me do things like look at the distribution of, start and stop times over time through some of the other tools that OpenRefine has. Let's try this again. Common transforms to date. There we go. Now I know that this has worked. Why? typography, always our friend. So it's turned these green. It means that they were a non-text data type. So I'll be back in a minute and we'll look at a little bit more of what we can do with this.